ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಇದು ಡಿಟರ್ಮಿನೆಂಟ್ಸ್ ಪಾರ್ಟ್ 9. ಇವತ್ತಿನ ಸೆಷನ್ನಲ್ಲಿ ನಾನು ಮೈನರ್ ಆ್ಯಂಡ್ ಕೋಫ್ಯಾಕ್ಟರ್ ಆಫ್ ಅನ್ ಎಲಿಮೆಂಟ್ ಈ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಇನ್ ದಿಸ್ ಯೂನಿಟ್, using minor and cofactor, we will learn to write the expansion of a determinant in compact form. ಹಾಗಾದರೆ ಮೈನರ್ ಆಫ್ ಎನ್ ಎಲಿಮೆಂಟ್ ಅಂದರೆ ಏನು? ಈಗ ಒಂದು ಡಿಟರ್ಮಿನೆಂಟ್ ಅನ್ನು ತೆಗೆದುಕೊಳ್ಳೋಣ. ಡಿಟರ್ಮಿನೆಂಟ್ del is equal to determinant of 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's find out the minor of each element. So I will show here how to find the minor of certain elements in this determinant. So the minor of element 1 is the determinant obtained by deleting the first row and the first column. 1 ಅನ್ನುವಂಥ ಎಲಿಮೆಂಟು ಈಗ ಫಸ್ಟ್ ರೋನು ಮತ್ತು ಫಸ್ಟ್ ಕಾಲಮ್ನಲ್ಲಿ ಇರೋದ್ರಿಂದ the minor of 1 is the determinant of the elements 5, 6, 8, 9, which is obtained by deleting the first row and the first column, because 1 lies in the first row and the first column. And the minor of 2, which is obtained by, just go through the determinant. 2 is the determinant, 2 is the element which lies in the first row and the first column. Leaving the elements of first row and the first column, the determinant of the elements, the remaining elements 4, 6, 7, 9, which is obtained by deleting the elements of first row and the second column. So determinant of these elements is the minor of 2. Now let's take some more other examples. Minor of 6 now. So 6 lies in the second row and the third column. Leaving the elements of second row and the third column, the remaining elements, taking the determinant of the remaining elements, that is 1, 2, 7, 8. This is 1, 2, 7, 8, which gives the minor of 6. So this is a determinant of order 3. Now the minor of an element is a determinant of order 2. It is all minors of the elements is a determinant of order 2. So from this conclusion, we can come to the definition. We can define minor of an element as minor of an element in a determinant as minor of an element Aij of a determinant is the determinant obtained by deleting ith row and jth column, in which element Aij lies. ಸೊ Aij ಎನ್ನುವಂಥ ಎಲಿಮೆಂಟು ith row ಮತ್ತು jth ಕಾಲಮ್ನಲ್ಲಿ ಇದ್ದಾಗ ಆ deleting the elements of the ith row and jth column, the determinant of the remaining elements is the minor of an element Aij. So now if you take the element determinant, suppose if we take the del as now 2 minus 3 5 6 0 4 1 5 7, then the minor of 0. Let's take, if let's take it as a problem. If del equals this, find minor of 0. So now 0 lies in the 0 lies in the second row and the second column. Leaving the elements of second row and the second column, the determinant of the remaining elements, they are 2, 5, 1, 7. 2, 5, 1, 7. So taking the expansion of the determinant, 2 into 7, 14, minus 5, that is equal to 9. So this is the minor of 0. This is how we can find the minor of an element. That is, which is obtained by deleting the row and the column in which the element lies. It is obtained by taking the determinant of the elements by leaving the row and column where the element lies. So ಇಲ್ಲಿ ಈಗ minor of ಈಗ determinant of order 3 ಅಂತ ಇದ್ರೆ, so minor of an element is a order 2 ಆಗುತ್ತೆ. ಹಾಗೆ minor in general we can conclude that minor of an element of a determinant of order n greater than or equal to 2 is a determinant of order n minus 1. So del is a determinant of order 3 and the minor of the each element is a determinant of order 2. Suppose del is a determinant of order 4, that is 4 by 4 determinant, then the minor of an element is a determinant of order 3, like this. So we can find the minor of an element. Now minor of the element Aij is denoted by capital letter Mij. So I denotes row, J denotes column. Now after defining the minor of an element, now let's define cofactor of an element. Now the cofactor of an element Aij denoted by capital letter Aij and is defined by Aij is equal to minus 1 to the power of I plus j into Mij, where Mij is the minor of the element Aij. Andre cofactor of an element gives the sign by taking minus 1 to the power of I plus j, where I denotes the row, j denotes the column, taking the sum of the suffixes of rows and column. This gives the cofactor of an element having a sign. So if I plus j is even, and it will become minus 1 to the power of I plus j is odd. So minus 1 to the power of I plus j is is 1 if I plus j, sum of the suffix is even, and minus 1 if I plus j is odd. So according to the sum of the suffix, we have the negative sign and positive sign. So cofactor of an element is the a denoted by aij is minus 1 to the power of I plus j into mij. Now let's consider one example, the minor and cofactor. Write the write the write the minor and cofactor of the elements in the following determinant. So in the determinant 1 0 4 3 5 minus 1 0 1 2. Now I shall find out the cofactor of the element. Before finding the cofactors of the elements, let's find out the minor of the element. So now minor of 1, that is that 1 lies in the first row and the first column. So that is minor of 1 is the 1 lies in the first row and the first column, leaving the elements of the first row and the first column, the determinant of 5 minus 1 1 2. So this we denote as minor of 1 is M11. So M11 means the minor of the element Aij lies in the first row and the first column. So now this is equal to 10 minus of minus 1. So 10 minus of minus 1 is 11. So this is M11. And now simultaneously I will finding cofactor of the element A11. This is what? Minus 1 to the power of I plus j. I plus j is I1 plus 1 into M11. So here we can find out cofactor of the element A11 is cofactor of 1 is minus 1 to the power of 1 plus 1. This is 1 plus 1 is 2. It is even. So therefore it is plus 1 plus determinant of that is 5 minus 1 1 2, that is we already find out equal to 11. Now let's find out the cofactor of the element 0. Before finding cofactor, let's take minor of 0. So 0 lies in the first row and the second column. So therefore we are writing M21. So this is the determinant of the elements. So 0 lies in the first row and the second column. So determinant of the elements 3 minus 1 0 2. This gives, taking the determinant, 6 minus 0 equals 6. Now cofactor of zeros, that is we can write this as A21, capital A21 is equal to minus 1 to the power of 2 plus 1 into M21. So that is equal to, so 2 plus 1 is odd number, therefore minus, and this is M21 is 6 here, therefore it is minus 6. Then cofactor of the element 4. To find the cofactor of 4, let's find out minor of 4. That is taken as 4 lies in the first row and the third column. So first row and the third column M13, that is equal to determinant of the elements, that is 4 lies in the, leaving the elements of the first row and the third column. So we have the remaining elements as 3 5 0 1. So 3 5 0, 1. Determinant of these elements is 3 minus 0 equals 3. So that is cofactor of these elements 0, that is cofactor of 4, element 4 is, that is minus 1 to the power of 1 plus 3 into m13. That is 1 plus 3 is even number, therefore it is plus m13 is 3. So it is 3 only. Now after finding, let's take m21. So m21, the element lies in the second row and the first column. So this is the element lies in the second row and the first column. So m21 we can write the minor of element 3. So this is 3 is equal to determinant of leaving the elements of second row and the first column, second row and first column, second row and the first column, second row and the first column. So we have the elements 0, 4, 1, 2. So 0, 0, 4, 1, 2. So that is 0 minus 4 is equal to minus 4. Now A21, that is cofactor of 3. Cofactor of 3, that is equal to minus 1 to the power of 2 plus 1, that is into m21, that is, this is minus 1 to the power of 2 plus 1 is, 2 plus 1 is odd number, therefore it is minus, m21 is minus 4. So I am writing minus 4, minus into minus 4 is plus 4. And now let's take m22. So m22 is the minor of the element lies in the second row and the second column. So the minor of the element lies in the second row and the second column is, element lies in the second row and second column is 5. So that is minor of 5. Minor of 5. So that is determinant of the leaving the elements of second row and the second column, leaving the elements of second row and the second column, the determinant of 1402. Determinant of 1402. Check it again. 1402. So that is equal to 2 into 1, 2 minus 0 equals 2. Now the cofactor of 5 is, that is A22. Cofactor of 5 is equal to minus 1 to the power of 2 plus 2, which is even number, into m22, that is equal to minus 1 to the power of 2 plus 2 is plus, and m22 is 2 here. So it is 2 only. Now minor of the element lies in the second row and the third column, that is the element minus 1. Element minus 1 lies in the second row and the third column. So leaving the elements of the second row and the third column, we have 1, 0, 0, 1. So that is minor of, let's take the element, minor of the element lies in the second row and the third column is minus 1. So minor of minus 1 is equal to determinant of. So leaving the elements of the second row and the third column, we have 1, 0, 0, 1. Therefore 1, 0, 0, 1, it is 1. Therefore cofactor of the element lies in the second row and third column, that is cofactor of minus 1. It is minus 1 to the power of 2 plus 3 into m23, that is minus 1 to the power of 2 plus 3 is, 2 plus 3 is odd number, therefore it is minus, m23 is 1. So it is minus 1. Now M31, the element lies in the third row and the first column. So that is the minor of the element. Minor of the element lies in the third row and the first column is 0. This one is 0. We have to take 0. So 0 minor of 0. Minor of 0 is the determinant of 0 lies in the 0 lies in the third row and the first column. So these are the remaining elements. So 0, 4, 5 minus 1. Determinant of 0, 4, 5 minus 1. That is 0 minus 20 is equal to minus 20. Therefore, similarly, we have A31, that is cofactor of 0 is equal to, that is minus 1 to the power of 3 plus 1 into M31, that is minus 1 to the power of 3 plus 1 is 3 plus 1 is even number, therefore it is plus, and M31 is minus 20, so it is equal to minus 20. Now let's consider M32, that is minor of the element lies in the third row and the second column. So that is third row and the second column is 1 here. So 0, 1, 2. So therefore minor of 1 is here. So that is the determinant of so 1 lies in the third row and the second column. Therefore the elements, the remaining are 1, 4, 3 minus 1. 1, 4, 1, 4, 3 minus 1. So taking the expansion of the determinant, so 1 into minus 1 is minus 1, minus 3 into 4 is 12, so it is minus 13. So A32 is cofactor of 1. The element lies in the third row in the second column. So minus 1 to the power of 3 plus 2 into M32. So minus 1 to the power of 3 plus 2 is, which is odd number, therefore it is minus. So M32 is minus 13. So minus of minus 13 is plus 13. So last element is the cofactor of the element lies in the third row and the third column. So third row and the third column is 2 here. So check it here 2. So the cofactor of, minor of, so this is minor of 2. Minor of 2. Minor of 2 is, that is equal to determinant of, the 2 lies in the third row and the third column. The determinant of the remaining elements is, that is third row, leaving the elements 1, 0, 3, 5. So 1, 0, 3, 5. 1, 0, 3, 5. So that is 5 minus 0 is equal to 5. So cofactor of the 2 is here. Cofactor of the 2 element is, that is equal to A33. Now that is minus 1 to the power of 3 plus 3 into M33. So that is plus, because 3 plus 3 is even number, therefore it is plus. M33 is 5. So it is plus 5. This is how we can find the cofactor and minor of the element. So directly it is better to find out the cofactor of the element directly using the sign. So the way of writing like this, that is writing the minor and cofactors, is very important in the expansion of the determinant. ಈಗ ಈ ಪ್ರಾಬ್ಲಮ್ ನಲ್ಲಿ we can come to certain results and we can get the certain conclusions. Now considering the determinant del again as determinant 1 0 4 3 5 minus 1 0 1 2 can be written as a11, a12, a13, a21, a22, a23, a31, a32, a33. So this you can write as equal to expanding the determinant 1 into 5 into 2 10 minus of 1 into minus 1 is minus 1 and minus 0 plus 4 into that is 3 minus 0 into 5 is 0. So I am expanding the determinant. So 10 plus 1, 10 plus 1 and plus 12. So 10 plus 1, 11 plus 12, 11 plus 12 is 23. So now consider the element, the sum of the products of the elements with their cofactors, that is a11 into a11 plus a12 into a12 plus a13 into a13. So what I am taking here, I have taken sum of the products of the elements, sum of the, this is sum of the products of elements, products of the elements with their cofactors. With their cofactors. So now I am taking this 1 into minus a11 is minus 1 to the power of 1 plus 1 into m11 plus a12 is an element 0. a12 is an element 0 and minus 1 to the power of 1 plus 2, the sum of the suffixes 1 plus 2 into m12 plus a13 here, a13 is 4. So 4 into minus 1 to the power of 1 plus 3 into m13. So now this you can write 1 into minus 1 to the power of 1 plus 1 is plus and m11, the minor of an element a11 andre 1. It is 5 into 2, 10 minus of minus 1, that is 10 plus 1 is 11. So just go back and find the minor of an element and write here, and 0 into minus 1 to the power of 1 plus 2 into m12. So 0 multiplied anything is 0, therefore I have written 0, and 4 into minus 1 to the power of 1 plus 3, that is 4 minus 1 to the power of 4, it is even number and it is plus into m13. m13 is m13 is here, m13, m13, m11 and m21, m13, minor of 4, it is 3 and a13 is plus 3. So therefore I am writing here plus 3. So 11 plus 12, 4 into 3, that is 23. So what we are getting here, the sum of the products of the elements with their corresponding cofactors is the determinant of the del. This is nothing but del. So now again consider this, will be taking that this, I am considering the second row a21, a22, a23, a21, a21 into cofactor of a21 plus a23 into cofactor of a23 plus a2, a21, a22, this is a22, a23 into cofactor of a23, this is a22. So what we are having, sum of the products of the elements with their cofactors is equal to, here we have taken the second row. So a21, so just you can take a21, a21 is an element 3 here. So here 3 into, and cofactor of a21, so just check it here, cofactor of a21 is 4 here, cofactor of 3 is this one 4, so this is 3 into 4 plus a22, a22 is an element, this is a22, that is 5, so 5 into 5 into cofactor of the element is 2, that is cofactor of 5, that is 2 here. So therefore it is 2 plus A23 is an element, A23 is an element. So here A23 is minus 1, A23 is minus 1 into A23 and cofactor A23 it is minus 1. So this is minus 1 here. So therefore it is minus 1. So here we have taken the second row. In the first case we have taken the first row and we have taken the second row here. So therefore this is 3 into 4 is 12 and 5 into 2 is 10 and minus 1 into minus 1 is plus 1. So that is, see, this is also 23, the value of the determinant then. So similarly, the sum of the products of the elements with their corresponding cofactor is the value of the determinant. So from this we come to the conclusion that we can evaluate the determinant along any row. Here we have taken the first row, in the second case we have taken the second row. So this is nothing but the expansion of the determinant in the cofactor in terms of cofactors and minors. Similarly, if we take the element A11, so I am taking A21. So this is the cofactor of the second row plus this is an element of the first row. See, observe that this is the element of the first row, second one is the element, the cofactor of the second row. So now A22, A12, let us take A12, A11, A12 into A22 plus and A13 into A23. See, second term is the cofactors of the second row, first terms are the elements of the first row. So what we are getting, let us see. Now A11 is an element, that is 1, 0, 4. A11, A12, A13. So A11 is 1 into A21 already find out 4 plus 0 into A22 is 2 plus A13 is 4. So A13 is here 4. So 4 into A23 is here minus 1. See what we are getting here? 4 in plus 0 minus 4. So 4 minus 4 is equal to 0. See, this gives sum of the products of the elements of elements of any row or column. You can take any row or column with the cofactors of the any other row. Very important, other another important element. Any other row or column is 0. So we can check with the other rows also. You can take the column which is the corresponding cofactors of the columns of the other row. So we can get the value as 0. See, with their cofactor, the sum of the products of the elements with their cofactor, you will get the value of the determinant. But with the other cofactors, you will get the value as 0. So this is the most important thing, and from this we can come to the very important conclusion that sum of the products of the elements with their cofactors is the value of the determinant. Sum of the products of the elements of any row or column with the cofactors of any other row or column is 0. So now let's prove these conclusions generally. So consider del is equal to determinant A11, A12, A13, A21, A22, A23, A31, A32, A33. So we have minor of the element A11 is leaving the elements of the first row and the first column. The determinant of the remaining elements is A22, A23, A32, A33. So taking the expansion of the determinant A22 into A33 minus A32 into A23, and minor of A12, that is the leaving the elements of the first row and the second column, the determinant of A21, A23, A31, A33. So taking the expansion of the determinant A21 into A33 minus A31 into A23. Then minor of the element A13. So A13 lies in the first row and the third column. So leaving the elements of the first row and the third column, so the determinant of the remaining elements is A21, A22, A31, A32. Determinant of this A21 into A32 minus A31 into A22. So these are the minors of the elements. Now cofactor of the element gives the sign. So from this I am going to write here cofactor of the element A11. We can write this as A11 is equal to, so that is sum of the suffix is even ಆಗಿರೋದ್ರಿಂದ it is plus expansion A22 into A33 minus A32 into A23. This is minus 1 to the power of 1 plus 1. And cofactor of the element A12, this is cofactor of element A12 is 1 plus 2 is odd number, it is minus of, because odd number minus, therefore A21 into A33 minus A31 into A23. And for this A13 cofactor of the element A13 is 1 plus 3 is an even number, therefore it is plus, therefore A21 into A32 minus A31 into A22. So expanding the determinant along R1 we have, so del is equal to, so minus 1 to the power of 1 plus 1 into A11 into determinant of A22, A23, A32, A33. So this is the very simple, this is equal to A11 into, so combining these two, that gives cofactor of the element A11. Then plus minus 1 to the power of 1 plus 2 into A12 into determinant of A21, A23 and A33 into A31, this is A31, A33 plus minus 1 to the power of 1 plus 1, 1 plus 2, 1 plus 3 into A13 into determinant of A21, A22, A31, A32. So this is plus, now I am writing this. So A12 into taking these two, that is the cofactor of A12, plus this is A13 into cofactor of A13. So this gives this is nothing but sum of the products of elements of R1 with the corresponding cofactors. Is the value of the determinant. So is the value of the determinant. So sum of the products of the elements of any row or column with their corresponding cofactor is the value of the determinant. So important thing here, the sum of the products of the elements of any row or column with their corresponding cofactors is the value of the determinant. This is the result 1. So now consider the sum of the products of the elements of the any row or column with the, now consider sum of the products of the elements of any row or column with their corresponding corresponding cofactors of any other row or column is 0. That we have shown by taking an example in the earlier case. So now this is another very important thing. This is sum of the products of the elements of any row or column with the corresponding cofactors of any other row or column is 0. So just one example you can take, that is you can consider the A11 into A21, the elements of the first row and the cofactors of the second row, A11, A21, A12 into A22 plus A13 into A23. So writing these elements, A11 into minus 1 to the power of 2 plus 1, cofactor of the element 2, 1. See, I am writing here, this is del as, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. So here cofactor of the element A21, this one, A21 is leaving the elements of the second row and the first column, the element as A12, A12, A13 and A32 and A33 plus A12 into minus 1 to the power of 2 plus 2, that is the cofactor of the element A22. So now determinant of leaving the elements of second row and the second column, we have A11 into A13 and A31 into A33 and plus A13 into minus 1 to the power of 2 plus 3 into determinant of leaving the elements of second row and the third column, second row and the third column, second row and the third column, we have A11 into A12, A11, A12, A31, A32. So writing this, I am writing this in the form of a determinant. So ಇದನ್ನು ನಾನು ಡಿಟರ್ಮಿನೆಂಟ್ ಆಗಿ ಬರಿತಾ ಇದ್ದೀನಿ. ಸೊ A11 ಈಗ ನೋಡಿ, this is A11 ಬರಿತಾ ಇದ್ದೀನಿ. So A11 we have to write the element minus 1 to the power of 2 plus 1 odd number. This is plus minus plus. So this is minus 1 to the power of 2 plus 1 A11. So this is the cofactor of the element A21. So A11, okay, 1 minute, this is the now writing the elements A11 expanding, this is minus 1 to the power of 2 plus 1 is minus into this is into A12 into A33 minus A32 into A13 and plus A12 into, it is positive, therefore into A11 into A33 minus A31 into A13 plus A13 into, it is minus 1 2 plus the odd number, therefore it is minus 1 into A11 into A32 minus A31 into A12. So now here it is minus, taking minus inside, minus A11 into A12 A33, taking minus, this will become plus A11 into A32 into A13 and plus A11 into A12 into A33 and minus A12 into A31 into A13. Here it is minus, therefore by taking minus inside and multiplying by A13. So A1 minus, this is minus A13, A11, A32 and minus into minus will plus A13 into A31 into A12. So now check the elements and compare. So this is minus A11, A12, A1, A33. So you observe this, A11, A12, A33. These two get cancelled. Now A11, A32, A13 cancelled with, see, A11, A32, see here, A11, A32, see the terms are interchanged but they are same, cancelled. So now this one, this is A12, A12, A31, A13. Now here observe this is gets cancelled. So ultimately we are getting 0. So from this we come to the conclusion that sum of the products of the elements of any row or column with their corresponding cofactor is 0. So these two results are important for getting certain conclusions later. Now we know how to find the minor and cofactor of the element. Now in the next section we are going to define the definition of adjoint of a matrix. Adjoint of a matrix. So here just I will introduce, next I will go through the properties related to adjoint in the next session. So what is the adjoint? Suppose if A is a matrix, A11, A12, A13, A21. This is I am taking the matrix 22, 23, 31, 32, 33. Now, so let's take the cofactor matrix of A. That is, the elements replaced by cofactors, its cofactors. The cofactor of A11 is replaced by capital letter A11, A12, A13, A21, A22, A23, A31, A32, A33. If the elements are replaced by their cofactors and they are called the cofactor matrix, then we define adjoint of the matrix. Adjoint of the matrix A, that is denoted by ADJ. Adjoint of A is the transpose of the cofactor matrix. Transpose of cofactor matrix. That means we shall write the transpose of the cofactor matrix as A11, A12, A13, A21, A22, A23, A31, A32, capital A31, A32, A33. So this is the adjoint of the matrix. So let's take the definition and the examples related to the adjoint and how to find the adjoint in the next session. Please go through how to find the minor and cofactor of an element in this session. After after knowing these results related to the minor and cofactor, we can understand the adjoint and the inverse of a matrix, and from this we can get the solution of the simultaneous linear equation. Thank you.